Hey guys, it's Medicosis Perfectionalis, where medicine makes perfect sense. Welcome back to my clinical biochemistry playlist. Let's first orient ourselves. In previous videos, we talked about disorders of carbohydrate metabolism. These included lactose intolerance, mild galactosemia, as well as severe classic galactosemia, essential fructosuria, and hereditary fructose intolerance. Now let's leave the carbohydrates alone and turn our attention to proteins and amino acids. In this video we'll talk about the amino acid derivatives, and in the next video we'll talk about amino acid metabolism disorders such as phenylketonuria, alkaptonuria, tyrosinemia, and others. Let's get started. Please watch the videos in this clinical biochemistry playlist in order. Here is my diet. When I eat proteins, I have to digest them into polypeptides, then oligopeptides, then dipeptides, which are made of two pieces called amino acids. Look at this. Amino acids are the building blocks for proteins. Two amino acids together, dipeptides, and then three tripeptides, a bunch oligopeptides, even more polypeptides. Then you go to become proteins. Don't forget the protein foldings and the structure of the protein. There's the primary structure, secondary structure, tertiary structure, and quaternary structure. We talked about them in great detail in my other biochemistry playlist. Why do we call them amino acids? My papa drives the Rolls Royce. Amino because they have an amino group. Acid because they have a carboxylic acid group. You have to start with the amino, then the acid. This is not arbitrary. This is how your ribosome synthesizes them. Amino group first, then the carboxylic acid group next. Amino acids are only 20, right? No. 20 proteogenic amino acids in the human body. But there are other amino acids, of course, such as the famous homocysteine, ornithine, taurine, and much more. Here are the 20 proteogenic amino acids. Each one has a name, a one-letter abbreviation, and a three-letter abbreviation. Pause and review. Let's talk about the derivatives that can come from amino acids. For example, phenylalanine is an amino acid. Tyrosine is another amino acid. They can become dopa, and then dopa will give me dopamine, which can give me norepinephrine. If I am in a nerve fiber, I will stop here. But if I am in an adrenal medulla, I can continue to become epinephrine. Dopamine, norepinephrine, and epinephrine are collectively known as catecholamines. Notice the word amine again. Catecholamines are catabolic, unlike the insulin, who is anabolic. Glycine is an amino acid. Glycine plus succinyl-CoA will give me protoporphyrin. Protoporphyrin plus the ferrous iron will give me heme. Heme plus globin will give me hemoglobin, which is located on my red blood cell, which carries oxygen or carbon dioxide. When it carries oxygen, it's called oxyhemoglobin. And when it carries carbon dioxide, it's called carboxyhemoglobin. Shut up. Carboxyhemoglobin is toxic. It's poison. It's carbon monoxide. When it carries carbon dioxide, we call it carbaminohemoglobin. Big difference. Carbamino when it's carrying carbon dioxide. Carboxy when it's carrying carbon monoxide. Next, tryptophan is another amino acid. It can give me serotonin, which can give me melatonin, or it can give me this crazy thing, which can become niacin. Depending on the dose, niacin could be a vitamin called vitamin B3, or it could be a lipid-lowering agent. Pharmacology is all about the dose, baby. And toxicology too. It's the dose that makes the poison. Saying that substance X is poisonous at any dose is as foolish as saying that a certain car is unsafe at any speed. What a bunch of bilge water. Next, histidine is an amino acid. It can become histamine. What do you call it when carbon dioxide is leaving the chat? Decarboxylation. Any decarboxylation reaction can benefit from vitamin B6 as a coenzyme. Similarly, glutamate can become GABA, which is an inhibitory neurotransmitter in your brain, including your basal ganglia, of course. When carbon dioxide is leaving, it's another decarboxylation reaction. The key enzyme will be called decarboxylase, of course. Now, this is not a derivative, but I just want you to remember that glycine, proline, and lysine amino acids are used to make collagen fibers. That's important. Now, let's discuss them very quickly. First, starting with the story of the catecholamine formation. Adrenal medulla story. Sing with me. Phenylalanine, tyrosine, dopa, dopamine, noradrenaline, adrenaline, or phenylalanine, tyrosine, dopa, dopamine, norepinephrine, epinephrine. If I am a nerve fiber, I will stop here at norepinephrine. But if I am an adrenal medulla, I can continue and become epinephrine because only the adrenal medulla contains the final enzyme, which is known as phenylethanolamine and methyltransferase. Where did you get the methyl group from? From Uncle Sam, the ultimate methyl group donor. Where did Uncle Sam get the methyl group from? From an amino acid known as methionine, which can come from homocysteine, if you have watched my previous videos on homocystinuria. So don't forget that your catecholamines came from phenylalanine and then tyrosine, etc., etc. When you metabolize these catecholamines, you get HVA and VMA. If I have a disease that's making too many catecholamines, like pheochromocytoma in adults or neuroblastoma in children, what do you think is going to happen? Elevated levels of HVA and VMA in the urine. Excellent. Moreover, this tyrosine has other options besides catecholamines. Tyrosine can help give me thyroxine or the thyroid hormone, and the same tyrosine can go the other way to give me homogentisic acid. More on that later. Moreover, tyrosine can also give me melanin. Why do we call it melanin? It came from a Greek word melas, which means black. Do you know a molasse? What's a molasse? Boy, does it have some sugar. Have you tried it before? Let me know in the comments. Tyrosine can give me melanin by a tyrosinase enzyme. And that's why many patients with pheochromocytoma or neuroblastoma have pale skin. Why is this? Because all of their tyrosine is consumed in making catecholamines, leaving less tyrosine to become melanin, so they get pale skin. Pallor is one of the 6 P's in pheochromocytoma, if you remember. Something that your professor will never explain to you. Why do they have pallor? Now you know. So we're done with the first story. The next story is heme synthesis pathway. Don't forget that your hemoglobin on the red blood cells is made of heme and globin. The globin is just a bunch of amino acids. Heme, however, is made of iron, ferrous, and protoporphyrin. And if we're talking about the story of the bilirubin, we can continue protoporphyrin, biliverdin, bilirubin, etc. Refer to my video about bilirubin and jaundice in my physiology playlist to learn more about the different types of bilirubin and the conjugation process, and the differences between bilirubin and bilinogen. So protoporphyrin plus iron equals heme. Heme plus globin equals hemoglobin. Let's go. Look at the heme synthesis pathway. Glycine plus succinyl-CoA. Many steps. Protoporphyrin. Protoporphyrin plus iron, heme. Heme plus globin, hemoglobin. What kind of iron is this? Is this ferrous or ferric? It's Fe2 because it's carrying O2, which means it is ferrous, and the name of the enzyme is ferrochelatase. See, medicine makes so much sense once you understand what the flip you're talking about. Next, the story of tryptophan. Remember, tryptophan is gonna give us 3 things: serotonin, melatonin, and niacin. Here is tryptophan, serotonin, melatonin, and niacin. Let's talk about that. Tryptophan, by an enzyme known as tryptophan hydroxylase, which requires tetrahydrobiopterin as a cofactor or coenzyme, will give me 5-hydroxytryptophan. Oh, you added a hydroxyl group, OH, at position number 5 on tryptophan, precisely. And then what? By an aromatic amino acid decarboxylase, because we're talking about an aromatic amino acid here, will give me serotonin. Just like this hydroxylase required tetrahydrobiopterin, this decarboxylase, when carbon dioxide is leaving the chat, requires vitamin B6 as a cofactor. Hey serotonin, where can I find you? You can find me in the median Raphe nucleus in the brain. Deficiency of serotonin there is associated with depression. That's the idea behind selective serotonin reuptake inhibitors. Where else can we find you? Enterochromaffin cells. The word entero means intestine, in your gut. Please refer to my video on carcinoid syndrome to learn more. What are the functions of serotonin? Vasodilation of vessels, but bronchoconstriction of bronchi. I'm a neurotransmitter in the brain. And don't forget that your gut has its own brain, so serotonin is there too. Serotonin can help the blood clot because it's part of the platelet granules stored in the platelets. And serotonin tends to increase peristalsis, which means there could be a link between depression and bowel movement, or eating disorders, or appetite dysregulation, etc. The aromatic amino acid decarboxylase enzyme converted the tryptophan into tryptamine. So instead of 5-hydroxytryptophan, now it's called 5-hydroxytryptamine. We're talking about amino acids today. We were introduced to catecholamines, and here is 5-hydroxytryptamine, which is the nickname of serotonin, abbreviated 5-HT. If you want to take serotonin to the cleaners, it will be metabolized into 5-HIAA, 5-hydroxy-indolacetic acid. But if you do not want to trash it and you want to utilize it, you can get Uncle Sam to donate a methyl group because it's the ultimate methyl group donor, and then serotonin will become melatonin. Instead of the median Raphe nucleus in the brain, it's in the pineal gland of the brain, responsible for the circadian rhythm. Quick comparison between serotonin and melatonin. Median Raphe, pineal gland. Mood regulation, circadian rhythm regulation. That was just one story of the tryptophan, but there is another story. The story of making niacin. And this requires FAD, which comes from vitamin B2. To give me niacin, which is vitamin B3. Which can give me NAD plus or NADP plus. Both of them are electron acceptors, of course. They can be reduced into NADH and NADPH, respectively. Lack of niacin or niacin deficiency is a condition known as pellagra, a triad of 3 Ds. Diarrhea, dermatitis, dementia. If not treated, you get the 4th D, death. Notice in this wonderful slide, you have been introduced to vitamin B6 as a coenzyme, vitamin B2 as a coenzyme, and vitamin B3 as an end product. And don't forget my tetrahydrobiopterin. Please pause and review. Note that the inhibitory neurotransmitter is derived from an excitatory neurotransmitter. Your body is amazing. And that's why studying brain circuits will make you lose your mind. Can this actually be beneficial? Yeah, if I have too much glutamate, it means I'm so excited. And of course, this can get into a vicious cycle and I can destroy myself, which means excessive glutamate can turn into the inhibitory neurotransmitter to inhibit the craziness so that I can calm down and behave like a normal person again. What did serotonin do? Vasodilation, but bronchoconstriction. Same thing with histamine. Vasodilation, you get anaphylaxis, etc. And bronchoconstriction, you get anaphylaxis, etc. Next, arginine and glycine and Uncle Sam as a methyl group donor can give me creatine. Creatine, by an enzyme known as a kinase, will become creatine phosphate because a kinase is an enzyme that adds phosphate. Creatine phosphate is part of the phosphagen system, which is a source of energy, especially for muscles, as well as for brain. We can capture that phosphate to convert ADP into ATP. To learn about the phosphagen system, refer to my video titled Muscle Metabolism. What's the end product of creatine metabolism? Creatinine, which is excreted in the urine. And in the lab, we can use this to estimate your glomerular filtration rate check out my labs playlist to learn more about GFR. But we're not done yet with arginine. It's true that arginine can give me creatine, but also urea and nitric oxide are derivatives of arginine. What does the word argenta or argenta mean? It means silver. And the country of Argentina is named Argentina. Why? Because it's the land of silver. Do you remember the silver stain in pathology or microbiology? You can call it the Argentophan stain. Argentina is the land of silver. Side note, why does Japan has a red circle in the middle of the flag? Because it's the land of the rising sun. Did they teach you this in school? Did they teach you anything in school? But you run around the house considering yourself, quote, educated, unquote. God help us. Why do I sound like an old guy? Do you remember my video on protein metabolism in my other biochemistry playlist? We talked about the urea cycle. Oh, look at this. Arginine is there too. And the urea cycle is very important to convert ammonia into urea, as well as to provide fumarate, which feeds into the tricarboxylic acid cycle or Krebs cycle, which gives me energy. Look what we have here. We have succinyl-CoA plus glycine equals heme. Heme plus globin equals hemoglobin, which is on your red blood cells. The same succinyl-CoA that made heme can also feed into the TCA cycle to give me ATP. Money. Oh, look what we have here. This is arginine again. It can give me nitric oxide. What's the name of the enzyme? Well, I'm trying to synthesize nitric oxide, so we'll call the enzyme nitric oxide synthase. Thank you, Captain Obvious. And what's the name of the cofactor? Tetrahydrobiopterin yet again. Some pearls for the pros: serotonin and bradykinin and histamine. All of them tend to dilate your vessels but constrict your bronchi. Take it to the extreme, you have hypotension here and you're wheezing here. That's how I demonstrate the adventitial lung sounds to my students. Pearls for the pros. Let's learn more about tetrahydrobiopterin. Here's the tetra. Here's the hydro, which means water, and bio. Alright, tetrahydrobiopterin. Have I heard of you before? Yes. You remember when phenylalanine became tyrosine by hydroxylase? I was there. Remember when tryptophan became 5-hydroxytryptophan and then 5-hydroxytryptamine? I was there as a cofactor for the hydroxylase. Remember when arginine became nitric oxide by the nitric oxide synthase? I was a cofactor there as well. Therefore, what do you think is going to happen to a patient who is born deficient in tetrahydrobiopterin? Well, no catecholamines. Not good if I'm running from a tiger. Not good in stressful situations. Not good if I want to raise my blood pressure. Not good in fight or flight situations. Not good if I want to make melanin, so expect pallor. Not good if I want to make thyroid hormone. Expect hypothyroidism. Not good if I want to make homogentisic acid and then, several steps later, fumarate, which feeds into the Krebs cycle. So therefore, lack of energy, maybe failure to thrive. What else is going on if I am deficient? Well, you cannot make serotonin. Oops, maybe I have depression. You cannot make melatonin. Circadian rhythm is toast. Sleep-wake cycle dysregulation or dysfunction. And you cannot make niacin. So I can get pellagra with the 3 Ds, diarrhea, dermatitis, dementia. And you cannot make nitric oxide, which is a famous vasodilator, especially in your coronary arteries of your heart. Oh, I have narrow or undilatable coronary arteries. Not good. If you get the physiology right, you can understand the pathology well. Because medicine makes so much sense once you understand what the French toast you're talking about. Why is anybody listening to me? Amino acid derivatives yet again. Pause and review. More pearls for the pros. In cases of a liver cell failure, such as in cirrhosis, the liver, may he rest in peace, is now unable to metabolize estrogen or metabolize ammonia or metabolize GABA. Because let me tell you, under normal circumstances, the liver take all of them to the cleaners once they have finished their job. Now, see what's going to happen when we cannot take them to the cleaners. Estrogen will go up, males will get gynecomastia, everyone will get spider angiomata, which is one of the stigmata of a cirrhotic patient. This is some old school Dr. James McKenzie kind of medicine. Was he English? No, Scottish. Next, when we cannot metabolize the ammonia, you get hyperammonemia, not good for your brain, ammonia encephalopathy, which can literally drive me mad and can give me coarse tremors known as astraxis. Moreover, when we cannot break down the inhibitory neurotransmitter in the basal ganglia, what do you think is going to happen? Abnormal movements, yet again. Aren't these common symptoms in cirrhosis? Yeah, because medicine makes perfect sense. Oh, by the way, forget cirrhosis for a second. Let's go to normal pregnancy. Oh, there is lots of estrogen, right? Right. Don't we have enlarged breasts during pregnancy? Yes. Don't we see some enlarged vessels, superficial vessels on the skin of the belly? Dilated veins and spider nevi? Yes, because these are caused by the hyperestrogenism. Nitric oxide dilates vessels. Nitrates dilate vessels. Hydralazine minoxidil are vasodilators. Sildenafil, tadalafil, vardenafil are vasodilators. Vasodilators can help me lower the blood pressure. You can learn about antihypertensives, anti-anginal, antiarrhythmics, antihyperlipidemics, diuretics, and digoxin by downloading my glorious cardiac pharmacology course on my website medicosisperfectionalis.com. Glutamate and aspartate are, for the most part, excitatory neurotransmitters in your brain. Conversely, GABA and glycine are inhibitory neurotransmitters. Learn more about neuropharmacology by downloading my CNS pharmacology course at medicosisperfectionalis.com. If you do not want to download my videos but would rather watch them right here on YouTube, click the join button, choose the highest tier to gain instant access to more than 300 premium videos right now. Please subscribe, hit the bell, support the channel here or here. Go to my website to download my courses, notes, and cases. Be safe, stay happy, study hard. This is Medicosis Perfectionalis, where medicine makes perfect sense.